Context OS, Agentic code simulations. Execution rehearsal for enterprise engineering. Production is no longer the test environment. The engineering crisis. AI is already writing code inside your organization, not because leadership approved it, but because developers need speed. Public AI tools deliver instant answers and rapid code generation. Teams are using them. But that speed introduces a silent, compounding failure mode. AI that infers without authority. Public AI doesn't know your architecture, dependencies, standards, risk boundaries, or historical decisions. Without enterprise context, developers compensate manually. As velocity increases, risk accelerates faster than oversight. There is no system-level code simulation to rehearse how these changes behave across the enterprise before they are merged into production. Code begins shaping revenue, customer trust, and regulatory posture, even though no one knows how those changes will behave in production. This is not a developer problem. It is a context and governance problem at enterprise scale. Why traditional tools fail? To understand why this problem persists, we need to look at the tools teams rely on today. IDEs optimize for individuals, not systems. Static analysis finds issues, not intent. Code reviews are manual and inconsistent. AI copilots generate code but don't understand the code base. These tools operate in isolation, optimizing execution, not decision quality. Together, they create 4 compounding failure modes. Context rot, dependencies changed since last review. Context pollution, irrelevant signals distort analysis. Context confusion, architectural intent is misinterpreted. Decision amnesia, similar changes failed before, but no one remembers. As systems scale, confidence drops, even as tooling increases. What's missing is not another tool. It's a system that connects engineering intent to governed action to verified outcome. Execution rehearsal, not testing. That system changes how engineering decisions are validated. Context OS enables execution rehearsal, proving system behavior before deployment, not discovering it after. Tests validate correctness against known cases. Execution rehearsal evaluates system-level consequences, architectural drift, dependency stress, policy violations, and downstream impact, before the change is accepted. At its core is a governed context graph that continuously models code structure, service dependencies, architectural patterns, engineering standards, and decision history. Unlike static dependency graphs, the context graph evolves from real engineering behavior, capturing not just what depends on what, but how decisions were made, under which constraints, and with what outcomes. As a result, simulation becomes a policy requirement, not a developer preference. But rehearsal alone isn't enough without enforcement. Context OS applies deterministic enforcement to engineering workflows. Changes that violate policy aren't blocked after review. The merge path structurally doesn't exist until all conditions are satisfied. Authority is explicit at every step. Who may propose the change? Who has authority to approve the impact? Under whose authority can the merge proceed? The system doesn't rely on reviewers catching issues. It makes violations architecturally impossible. Governance boundaries are absolute. The code simulation agent does not auto-commit, bypass pull requests, override code owners, modify protected paths without authorization, or deploy to production. AI assists. Engineers decide. Policy enforces. Progressive autonomy. With clear boundaries in place, autonomy can expand safely. The agent operates under progressive autonomy. Shadow, simulates and logs. Assist, recommends with human approval. Delegate, auto-approves within defined risk boundaries. Trust benchmarks gate transitions, simulation accuracy, escalation appropriateness, and lineage completeness. If benchmarks slip, authority contracts automatically. Trust is earned, not assumed. Complete decision lineage. As autonomy grows, traceability becomes critical. Every change decision is recorded with complete lineage, not just what changed, but why, what alternatives were considered, and what risks were knowingly accepted. For example, a minor change in a shared authentication library is simulated across downstream services. Increased latency in a regulated payment flow triggers a PCI violation and escalates to security before the pull request merges. Years later, auditors can trace exactly why that decision required review. Enterprises deploying execution rehearsal consistently achieve reduced pull request cycle time, earlier detection of architectural and security risks, fewer late-stage reversals, stronger alignment between velocity and safety. This is not code generation. This is governed decision intelligence for engineering, contextual, predictive, and defensible. Now let's see the live demo of it. ElixirData integrates seamlessly with enterprise identity systems. Users authenticate securely using existing Microsoft credentials, ensuring compliance with organizational access policies, while maintaining a smooth, password-free experience. ElixirData provides an agent marketplace where agents are purpose-built for specific enterprise workflows. Each agent comes with a clearly defined scope, access boundaries, and governance controls. From the marketplace, the Agentic debugging and code simulation agent is selected, an agent designed to launch simulated environments, to simulate real-world scenarios, validate behavior, and test fixes safely before production. It initializes its reasoning engine, execution policies, and context memory required for simulation workflows, including environment orchestration, test execution, and scenario replay. Now we have a safe simulated space to reproduce and validate behavior without risking production. The agent is now ready to operate. ElixirData recommends the required enterprise connections. Based on the selected agent, the agent requests access to GitHub for source code understanding and version history, Jira for issue context, scenarios, and acceptance criteria, Confluence for architecture, workflows, and system contracts. These connections allow the agent to simulate and test using the same information humans rely on. A live code and incident context graph is created that understands repository structure and dependencies, service boundaries and ownership, workflow rules and integration contracts, historical changes and recurring failure patterns. No manual documentation. Context remains live, consistent, and trusted. A Jira issue created which say customer message not delivered even though workflow conditions were met. System generated a platform notification for this issue. It converts the ticket into executable simulation scenarios, including normal workflow path, high-volume customer segments, pagination or rate limit boundaries, retry and timeout combinations. This turns a vague bug report into a repeatable, testable simulation plan. The agent executes the workflow inside the simulated environment. It replays the message flow end-to-end, then inspects workflow rule evaluation, API responses and pagination behavior, data retrieval completeness, downstream delivery triggers. The simulation confirms the customer met the conditions, but the record was skipped due to an API pagination limit, a boundary case that production traffic exposed. Now the agent applies a fix inside the simulated environment first. It updates the logic to correctly handle pagination and ensure all eligible records are processed. Changes are minimal, scoped, and aligned with existing coding standards. No production changes yet, only safe, isolated validation. The agent simulate existing regression suite, integration simulations across dependencies, new tests generated specifically for this edge case. The new coverage ensures the issue can't silently return when traffic scales. All validations pass successfully in the simulation environment. The agent generates a structured human-readable report including scenario executed, root cause discovered during simulation, fix applied, test simulation results and coverage summary. Every step is traceable, explainable, and auditable. After simulation validation, the agent creates a GitHub pull request with full context. Reviewers can see exactly what scenarios were simulated, why the fix was needed, what changed, how it was validated in simulation. The agent accelerates resolution while keeping humans fully in control. The agent updates the original Jira ticket with simulation reproduction summary, root cause, fix reference, test evidence and validation results. The issue lifecycle is completed with transparency and governance. This is what software engineering looks like when agents operate with simulation-first execution, not reactive debugging, not production firefighting, but safe environment launch, scenario replay, validation by proof, and human-in-the-loop delivery, powered by ElixirData and Context OS. Discover ElixirData Context OS. Book a demo with us today.